Alright, this is page 4 of the first semester review. So on 30, there's a couple of different ways we can handle this one. If we remember that y equals mx plus b is the formula for the slope-intercept form of a line. M is the slope, b is the y-intercept. So this has a slope of 7. So the number in front of x should be a 7. So there's two of those that it could be. So it can't be these two. And then to find the other value, we could do it one of two ways. If we were going to do it by hand, the way we do it, if we didn't have multiple choice, we have our x and our y. Let's actually use a full-size table here. So if we have an x and a y, our x point is -1, and our y point is -4. And we know that y is equal to 7 times x plus something. Alright, so 7 times 1 is -7. So -7 plus 3 is 4. So that's going to be our answer. The other way we could have done this on the calculator is we could have just taken these two different values and put it in our y equals and seen if it's on the table or not. So go second table, and we see the point -1, -4 is on that table, so it would be D. Again, I'm not going to circle all the answers on here just because I want students to actually listen to the tape and not just try to watch it without listening. For number 31, it says for this function, find the range when the domain is 0, 1, 2, and 3. So remember, domain is just the x values, and range is just the y values. So all we have to do is go into our calculator and put this function in and look on our table for these x values. So when x is 0, y is -2. So it could be this one, but it also could be this one, so we have to check the other values. So when x is 1, y is 6. When x is 2, y is 14. And when x is 3, y is 22. So it is A. For number 32, again, this one's very simple. We could just plug these different values into this equation. So x is -1 and y is -6. But since we have the calculator, we can just plug this function in. X -4, and then go to our table and see which of those points is there. So -1, -6 is not there. 0, -4 is. We went to 2, that's not right, and 5, that's not right. So it is 0, -4. For 33, just take a look here on this graph. So here's the equation, 4x plus 3, and he's going to shift this thing up for the y-intercept to be, actually he's going to shift it down for the y-intercept to be -3. 1, 2, 3. But he leaves the slope alone, so it's still going to be up 4 over 1, up 1, 2, 3, 4 over 1. So let's see which one of these is the same. So keep the same steepness, but crosses the y-axis at a different point. That one looks pretty good. Same steepness because the slope didn't change and just went down some. Be steeper or flatter, but still cross the y-axis in the same place? No, because we shifted it down. Be exactly the same? Of course not. Have nothing in common with the original graph, and that's of course not right either. So the answer would be that it has the same steepness because the slope did not change, but crosses the y-axis at a different point. All right, for 34, this is very similar. I'm sure you can figure this out by now if you couldn't before. Which of the following points is not on the line of y equals 2/3 x plus 4? So we're just going to put that in, 2/3 x, very similar to the one we had before, 2/3 x plus 4, and we just simply go on our table and see if they're there or not. So 0, 4 is there. I'm going to check -3. -3, 6 is not there. If we go and check the rest of them, they should be there. 6, 8, and 7, 10 is not there either. So actually I think we may have a mistake here. -3, 6, and 7, 10 are both not on this graph. So either B or D would be correct. I don't think that was intended when we wrote this review. So which kind of association, for 35, which kind of association exists between the amount of water in a bathtub and how long the water has been running? So for this one, you might want to draw a little graph. So our independent variable is time that it's been running, and the dependent variable is amount of water. So the tub, we're going to assume, started empty, and then as time goes on with it running, it's going to get more and more water in the tub. So this would be a positive association, because as x is going up, y is going up. It's also a positive slope. So positive association. So for number 36, find the equation of a line that is perpendicular to y equals 1/3 x minus 9 with a y-intercept of 9. So if we remember that perpendicular, we flip. Perpendicular means that they're perfectly square to each other with a right angle. So we flip the fraction and make it negative. So the slope is going to be 3/1, because we flipped it, and we make it negative. So it's going to be -3. So there's actually already only one choice of those. But the y-intercept is 9, so in y equals mx plus b, b is the y-intercept, and that would have to be 9. The slope would be -3. So it's -3x plus 9. So for the next 3 questions, we've got a little process we need to do here. So it says a line passes through these 2 points. So we're going to take a look at our little table over here. And we have x and y. So x is 1 and y is 3, and x is 5 when y is 23. So we need a slope. So the slope here is going to be change in y over change in x. So x went up 4 and y went up 20. So change in y is 20, change in x is 4, 20 divided by 4 is 5. So the slope of this line is going to be 5. So what is the y-intercept of this line? Okay, so to do this, we're going to have to finish out this formula. So we have 5 times x. We have 5x plus or minus something to give us y. So let's see if we can figure out what that is. So 5 times 1 would be 5, plus or minus what equals 3? That's minus 2. So our formula is 5x minus 2. So y equals 5x minus 2, so the y-intercept would be -2, or 0, -2. So then to check this one, we just put those 2 values in to this formula and see if that's going to work. So if I put in 3 and 13, So 5 times 3 is 15, minus 2 is 13. So yes, it's true that that one does fit the line. You could also at that point, if you wanted to, put that in here into y1 and go to the table and see if that point 313 is on the line, and it is. Alright, this video is getting a little long, but I do want to do one video per page, so we're going to see if we can move it along. Which type of correlation is shown in the scatter plot below? So since it doesn't seem to be trending up or seem to be trending down, there is no correlation. So solve for x. You could do this two ways. You could just put it in the calculator, so you could just put in this formula. So you could put in negative 5 times 9x plus 7 into y1, make sure you get your parentheses in the right place, and put 100 into y2, and go to your table and see where y1 and y2 are the same, which is right here at negative 3. So x equals negative 3, or we could solve this by hand, and you should be able to do that by now. 5 times 9x plus 7 equals 100. So we distribute negative 45x plus negative 35 equals 100. Need to get rid of this, so plus 35 plus 35. We're going to cancel here, and we get negative 45 equals 135. 45x, pardon me. Divide both sides by negative 45, and you get x is equal to negative 3. Alright, so number 42. Which of the following equations represents a vertical line? So if we look on y equals 6, if y is 6, no matter what x is, so when x is 0, y is 6, y is always 6, that would be a horizontal line, and x equals 8, no matter what y is, x is always equal to 8. That would be a vertical line. So in 42, x is equal to 8 would be a vertical line. Alright, and the last one here, number 43, negative 7 divided by 0. We're assuming, of course, we'll use this a lot in slopes, but in any case, negative 7 divided by 0 is undefined. You cannot divide by 0 because we don't know how many times 0 goes in. If you're not sure about remembering that, you can always just go to your calculator here and go negative 7 divided by 0, and it's going to come up error divided by 0 because we can't divide by 0. So number 43 is undefined.